This video is going to be about an application of Bernoulli's equation, which is the Pitot tube, which is a tube used to measure airspeed. Inside a Pitot tube, there is a tube shaped like this. Surrounding the outside of the Pitot tube, there's a case with a hole here and a hole here. So this means there's 2 points, A and B, that are going to be used to make pressure measurements with the Bernoulli equation. The hole in the front of the Pitot tube is where moving air comes in. And I've labeled this hole B. So the moving air comes in, but there's still air inside the tube, and this brings the air being pushed into the tube, the moving air being pushed into the tube to rest. Now, the moving air pushing into the tube and being brought to rest causes a pressure difference, which causes the fluid which sits inside this inner tube to be more pressure on the right side than on the left side. This causes a difference in the height of the fluid between the right and the left, which means we can use this information to find the airspeed. I'm going to write out Bernoulli's equation without the height terms because there's very little height difference between A and B. Now I'm going to look for things that I might cancel out to simplify this equation. So I know this sounds counterintuitive, but the air entering hole B and then encountering the still air becomes still air. So the speed through hole B I can say is 0 because that air was brought to rest. And so the equation simplifies to the pressure on side B plus or equals the pressure inside A plus 1/2 V times 1/2 the density of the air times the speed of the air squared. Okay, I can simplify this equation, or I can isolate airspeed. All right, so I've isolated airspeed, and I could use this equation, but I don't actually know what the pressure is at B and the pressure is at A. But if you'll notice, this looks a lot like a manometer, so we can use the manometer equation we learned earlier. So pressure B is equal to pressure A plus rho of the, or density of the liquid. So this is important that I'm making the distinction between the density of the liquid now, because before we were talking about the air's density. So this is the manometer equation, and notice I can substitute this in to pressure B here, giving me the equation that the airspeed is equal to the square root to the density of the liquid, the acceleration of gravity, times the height difference in the water, or in the liquid, divided by the air's density. All right, that's the end.